I'm going to do some exam solutions for this practice test, and hopefully this will help you get ready for the exam on Monday. Now, with all these problems, we want to have free body diagrams. So for question number 1, 2, and 3, I'm going to just use the free body diagram. I'll just recycle it for each problem. And when we read the question, we see that we have the following forces acting on the car. We have an engine force, friction, normal, and weight. Now, what we want to do is get the net force on the car. Now, if we're doing it with this side, we're using the free body diagram. If we're doing it on this side, we're getting the mass times the acceleration. We don't really know all the forces in our free body diagram and what their values are, so we're going to have to use the acceleration. So to do that, I'm going to use a kinematics formula that you'll get from your exam sheet. So again, 60 equals A times 10 plus 40. And so I'm getting A equals 2 meters per second squared. So to get the net force, I will take M times A, and I will actually get an answer of 2,000 newtons because this is M. I'll put it in there. A I just solved for here, and so I'm getting 2,000 newtons worth of force. Now, continuing, if the coefficient of friction is 0.4, what is the friction force on the car? Well, we know that friction is mu times N. That's mu kinetic times N if it's kinetic friction. And the fact is, we know that the force is balanced in the y direction from the free body diagram. And so we're going to need to plug in some numbers here. We're going to get that the normal is 1,000 times 9.8. Not because the normal is the same thing as the weight. It just happens to balance with the weight in this particular problem. So we'll take 0.4 times 9,800. And when we go ahead and do that, we're going to end up getting 3,920 newtons. And then the last problem that we'll do, well, now what's happening here is that we are accelerating our car, and we need to write down the equation for the unbalanced force in the x direction. So we have the engine force minus the friction equals m times a. Again, I'm reading off this force, subtracting off that force, and the effect is that the car accelerates. So we're going to actually then take the engine force minus 3,920, and the effect of that is going to be the 2,000 newtons that we got here. So really I'm using the answers to 1 and 2 to solve this, and then I finally get an answer of C, 5,920 newtons as the engine force. Now granted, this is a very simplified model of a car, but it's effective for what we want to do in this class.